In the last lesson, we looked at how we can solve for non-right angle triangles using the sine law. Now we're going to look at the cosine law. So that's going to be when we have different qualities for a triangle that we're trying to solve. So first, if we consider the triangle ABC to the right, where A is 36 degrees, the length of A to B is 3 centimeters, and the length of A to C is 6 centimeters, what happens when you try and use the sine law to determine the length of BC? Well, for the sine law, we need to have an angle and the side length opposite. Well, I don't know what this side length is that's opposite of the angle that's given. And because I don't have two angles, I can't solve for the third angle, which means there's no way for me to solve for what this angle is or what this angle is. Which means that I don't have enough information to actually use the sine law. So, in the example above, we're given the lengths of two sides and the contained angle, or side angle side, like we learned in the last unit. The sine law is not applicable. We can find the length of BC by making a right angle triangle where we're going to expand out the length of AB to a third point of D and creating this right angle triangle that exists here. Now, with this information, I can solve for what the opposite side length is, or the length of C to D, by just using my sine ratio. I can say that sine of 36 degrees is going to equal the opposite side length, CD, divided by the hypotenuse, which in this case is going to be that 6. Which means that 6 times sine of 36 is going to equal CD, which is going to be approximately 3.53 centimeters. At the same rate, I can solve for what the length of A to D is using the cosine law, or cosine ratio, where in this case, the length of AD, well, that's going to be the adjacent. Here I still have my hypotenuse, which means that cos of 36 degrees is going to equal my adjacent AD divided by my hypotenuse of 6, which means that 6 times cos of 36 is going to equal AD, which means that approximately 4.85 is going to equal AD. Well, the length of B to D here is just going to be that entire length of AD minus that 3 centimeters, which means that BD is going to equal 4.85 minus 3, or 1.85 centimeters in here. Now, I can use the Pythagorean theorem to figure out what the length of BC is. Because that's going to be my hypotenuse, I'm going to say that the length of BC squared is going to equal 1.85 squared plus 3.53 squared, which means that BC squared is going to equal 15.8834, or BC is going to equal the square root of 15.8834, which is going to be about 4.0 centimeters. So it's going to round to 4 centimeters. Now, if we're figuring out why the cosine law works, well, the diagram shown is a right angle triangle, just like what we did in the last case, where triangle ABC is placed with AB along the base and A at the origin. The line CD is drawn perpendicular to AD, creating this height, or the right angle triangle. And in this case, I could say that A to D is x units, which is stated here, and that D to B is going to equal the side length of C, so the side length opposite angle C, minus the x units is what's going to be in this side here. Now, this is a more complex formula than the sine law one, which we're going to see why in just a second here. So, if I'm filling in the information, well, for triangle BDC, which is going to be this right angle triangle here, then if BC squared, so the side length squared, is equal to CD squared, this height squared, plus DB squared, this length squared, then all they did was replace it with the things we know. We know that BC is going to be the same as A, we know that CD is going to be the same as H, and we said that DB is the same as C minus X squared. So they squared out this using FOIL and said that's the same as C squared minus 2CX plus X squared. Then all they did was they moved the X squared over to the H and combined that together in grouping, and then said that we have the C squared minus 2CX. So when I have the H squared plus X squared, well, H squared and X squared are going to be the two sides that exist here. The value of H squared plus X squared is the same as the hypotenuse of B. And X is going to be the same as B cos A. Because if I have angle A and I multiply that, or take the cos of that and multiply it by the hypotenuse, it's going to solve for my adjacent, which means that X is the same as B cos A. So I get A squared is equal to B squared plus C squared minus 2BC cos A. Now, if that works for one side of the triangle, it's going to work for the others. So if I think of it, it's going to be, if I have one side length, it's going to be the other two side lengths squared and added together, minus 2 times the other two side lengths, and cos the angle that is opposite the side length that we have isolated. True every single time. If I have B squared, then it's going to be the other two side lengths, C and A squared, minus 2 times the other two side lengths, C and A, and cos the angle that is opposite the side length that we have isolated. So this version of the cosine law can be used in any triangle if we're given the lengths of two sides and the contained angle SAS. So anytime that I have two side lengths and the angle between them, this is the formula I'm going to use to find the other side length.